All right. If we're looking at a situation where we have, for instance, the hydronium concentration, and let's say, for instance, we want to actually figure out the pOH from that, we actually have two strategies we can go with. Because there's two things that we can actually convert the hydroxide, or um, there's two things that hydronium, the H3O, can be turned into easily. Um, and one of them is the pH, and the other one is the OH concentration. Now, on this top arrow, to convert from H3O to pH, we have this equation. The pH is equal to the negative of the log of the hydronium concentration. So if, for instance, I had given you a hydronium concentration of, let's just make up something, 3.0 times 10 to the negative fourth, then my pH I would get by taking the negative log of 3 times 10 to the negative fourth, giving me a pH of 3.52. And then if I want to convert that pH into a pOH, the equation I'm going to use is fact that pH plus pOH always adds up to 14. So if I do 14 minus that value, I get a pOH of 10 point, let's see, that's 48. All right, now the other option we have is to convert to the OH concentration first. And I'm going to do that, we'll go with orange. And that relationship, we have this wonderful relationship that Kw equals the OH concentration times the H3O concentration. And Kw is 1 times 10 to the negative 14th. So if I were to take that 1 times 10 to the negative 14th and then divide it by, in this case, the H3O concentration of 3 times 10 to the negative fourth, we get something like 3.33. I'll put that here. Now watch the exponents here. I don't have that many digits. Because what is possible is that you end up with the wrong exponent. So what if your calculator is giving you the wrong exponent? The solution is probably to put that number, that 3 times 10 to the negative 14th, in parentheses. So might be, if you're getting the wrong exponent, try doing it with the 3.0 in parentheses. Now, technically speaking, on a TI, if you're using that times 10 to the negative fourth with the little capital E, it's going to work always, because TIs understand how to use that EE with the order of operations. But if you're not getting the right exponent, try putting that bottom number in parentheses like I just did. All right. Once you have the OH concentration, you can turn it into the pOH by an equation similar to that thing up on the top of here. pOH is the negative log of the OH concentration. So I'm going to do negative log, negative log of that value. And I get that 10.48 again. All right, now going backwards, we have two very similar equations. So what we're going to do on this one is start with the pOH and find the hydronium concentration. Now, probably the easiest way would be to go to the pH first, and then from the pH to the hydronium concentration. And we'll use that same equation we did before to relate the pH to pOH. And that is, those two add up to 14. So let's do, on this case, we're going to give a pOH of, let's do 11.41. So if I have that, then the pH is the difference between that and 14. We get something like 2.59 for a made-up value here. All right, now if I want to go from pH to H3O, trick is to realize the secondary function of the calculator tells you what we're doing. So since the pH to hydronium was an equation that looks similar to that, going backwards, we're going to see the hydronium ion concentration is that secondary function of logs, 10 raised to the negative of the pH. So if my pH is 2.59, ten to the negative 2.59 should give me my H3O concentration. I'm going to put this in scientific notation. 2.5, 2.6 times 10 to the negative third. Now, we could go the opposite, that top of this one here. So if I wanted to convert the pH to, or the POH into the OH concentration, I have a similar equation to this one. OH negative is equal to 10 to the negative POH. If that's the case, our OH concentration is, let's see, 10 to the negative, and my POH was the 11.41. Put it right there. So I get a hydronium concentration, or hydroxide concentration, of 3.9 times 10 to the negative 12. And the last conversion to complete this full thing, going from OH to H3O, we're going to use that equation Kw equals the OH times the H3O, which is the same thing we used up here. So I'm going to take 1 times 10 to the negative 14th divided by the 3.9 times 10 to the negative 12th, and I get that same value again, 2.6 times 10 to the negative third. And that gets us a full cycle of how we convert any of our pHs or OHs or hydroniums or hydroxide, how they all relate to one another.